You should have your classwork packet out, and we are on that last page of the classwork working with imaginary roots. So suppose you were given this polynomial x to the fourth minus x cubed plus 3x squared minus 4x minus 4. And we were going to try and factor this and come up with what the roots are and perhaps graph it and find all this information out. So you would start with your possible rational roots. Notice that there is no leading coefficient, or it's a 1. So my possible rational roots are just going to be plus or minus 1, 2, and 4. I'm actually going through the problem that they talk about. We are just looking at the first half of the page on the classwork portion. We are not doing the second one, so it doesn't really have a number, it looks like. But I'm going to be going through it in its entirety. So here are our possible rational roots. So if we go ahead and we do like we've done before and plot or graph, we're not going to graph it, but go ahead and enter this into your calculator and then set up, I have my table set like this with the increments of 1, since they're all integer values that are our possible rational roots. And then I'm going to look at the table. And remember, I'm looking for a 0. So -4, nope. -2, -1, nope. If you scroll down, you see there are none. There are no rational roots. So now I'm going to go ahead and graph this. If I zoom 9, oh, I didn't mean to do zoom 9. That was for trig, for stats. Zoom 6, let's try. So here is my graph. We can see it does have root, it crosses. We know that it does cross, but they're not rational roots, so I can't find them with synthetic division. So if we didn't have any other information, we wouldn't know what to do at this point. But we do. So suppose you're told, suppose you know that 2i is a root. Okay, well, we can actually do synthetic division even if we have an imaginary number. Now, remember that complex numbers always came in pairs. So if 2i is a root, then so is -2i. We always ended up with plus or minus whenever we had a situation like that. So we know that if 2i is a root, then -2i is also a root. Also remember, and this is some of the information, actually, let me go back to your notes. I kind of took us up to this point. So first, just a review on imaginary numbers. Remember that I squared equals -1. Okay, so you got to remember that. I squared equals -1. And then remember how you use when you are multiplying. So like if you have to multiply I times 2i minus 1 and you distribute that, you get 2i minus I squared. But remember, anytime you see an I squared, you replace that with a -1. So you would change this to 2i minus a -1, which would be 2i plus 1. If you were multiplying I minus 4 times 3i plus 1, you can FOIL that. And when you do, you would get 3i squared for the first term plus I minus 12i minus 4. But then you have to remember I squared is -1, so that changes this to a -3. Combine like terms, I minus 12i is minus 11i, and then you would have still a minus 4, and then this -3 minus 4 becomes -7. So you can do imaginary number math on your calculator. We haven't really done that, but if you want to, you can, and this is what you do. It's not the greatest, but if you hit the mode key and you go to, instead of real numbers, which is right down here, you go to a plus bi. And if you select that, then if you wanted to do something, I'm going to just show the example they have. So I minus 4, to get the I, it's the decimal point, so you hit second, and then we have I minus 4. times 3i plus 1, and voila. Now, I don't typically do that. I just find it easier just to work it out. So I'm going to switch my calculator back to real mode, but you know, it's a possibility if you choose to do it that way. All right. So I'm going to set up the synthetic division. You do have this on your classwork page that you could, if you can squeeze it in there. So just like we have done before, we're going to bring the first number down. Then we multiply. So 2i times 1 is 2i. And then I'm going to add. And when I add, I get 2i minus 1. Okay, because I can't combine them. They're not like terms. So then I'm going to multiply. Now when I multiply, I'm multiplying the 2i times the 2i. And when I do that, I get 4i squared. So when you multiply and you get 4i squared, remember I squared is negative 1. So I'm going to change that to a minus 4. 4i squared is the same as negative 4. And then I multiply 2i times a negative 1 and I get minus 2i. And then I add. And so when I add these, I combine like terms. So 3 plus negative 4 is negative 1. And then this minus 2i kind of tags along. And now I'm ready to multiply again. So 2i times negative 1 is negative 2i. And then I have a minus. 2i times 2i is 4i squared. But remember, I squared is negative 1. So 2i times 2i is negative 4. But it's minus a negative 4, so it's going to change it to a plus 4. And then I add, and the 4's cancel out. I'm left with negative 2i. And I multiply 2i times negative 2i is negative 4i squared. But remember, I squared is negative 1. So negative 4i squared is the same as a positive 4. And then I get a 0. Well, that's kind of how I know I did it right, because I got a 0. If 2i is a factor, then my remainder has to be 0. So then, now we're ready to do synthetic division again with a negative 2i. Now, they just took this row right here and recopied it here. So here's the 1. I had 2i minus 1. They changed it to negative 1 plus 2i. Minus 1 minus 2i, you see that? And a negative 2i. Okay, so they just recopied that to do synthetic division, or you could have just, moved it down. So we bring the first number down. Negative 2i times 1 is negative 2i. This one you're going to like. You'll see why in a minute. When you combine these cancel out, you have a negative 1. Negative 2i times negative 1 is a positive 2i. When you add like terms, these cancel out, you're left with negative 1. Negative 2i times negative 1 is positive 2i. And when you combine those, you get 0. And that's how you know you did it right. So this is our depressed polynomial. So now we're going to actually take this. So we know that we have x minus 2i for this first factor, and we have x plus 2i for this next factor, for the second one. Remember, if 2i is a root, x minus 2i is a factor. If negative 2i is a root, x plus 2i is a factor. And then this is going to be, we started with x to the 4th. We went down 2, so this means this is x squared minus x minus 1. Now, this does not factor anymore. This is awkward, so I don't want to leave it with i's in it. So I'm going to multiply that out in a box. So we have x minus 2i, x plus 2i. And, okay, that totally was wrong. Too bad I can't rewind this. X minus 2i, I don't even know what I was thinking, x plus 2i. So we get x squared minus 2xi plus 2xi. And then here I have a negative times a positive, so it's going to be negative. And we're going to get 4i squared. Well, these cancel out because they're opposites. Remember, I squared is negative 1, so I get x squared. That changes this to a positive 4. So we end up with x squared plus 4 and x squared minus x minus 1. This is my factorization. But it's not my roots. We already know 2 of the roots. We already know 2i and negative 2i are roots. We need a root from here. So x squared minus x minus 1 equals 0. Quadratic formula tells us x equals the opposite of b, so that would be a positive 1, plus or minus square root b squared minus 4ac all over 2a. So we have 1 plus or minus the square root of. So this is 1 plus 4. So then I get my other 2 roots. So my roots are 2i, negative 2i, 1 plus the square root of 5 all over 2, 1 minus the square root of 5 all over 2. So those would be my roots. This would be my factorization. That's how you would have to do it. We would not have been able to do this if we had not been told that 2i was a root, and then remembering that if 2i is a root, then negative 2i is also a root. Now, there is another example on here where they tell you where the root they give you is a sum or a difference. Those can get a little more complicated, so I'm choosing to skip that. And on the homework, you are doing number 10 from the homework packet. You are only doing parts A and B, because that way you don't have to deal with a sum or a difference. Don't do parts C and D unless you want to look at this example and you want to. Then if you parts A and B are going to be like this one that I did. So hopefully that helps so that you can deal with working with imaginary roots.